Okay, Geometry, Chapter 4, Section 2. We're looking at reflections. Again, not going to change the size in these, just going to change the direction. Just kind of like looking at your reflection in the mirror or looking in a rear view mirror or side view mirror or something to that effect. Maybe something off of a when the lake is really smooth like glass and you might be able to see a reflection of certain things. So we're going to just do some basic to start out with, some vertical and horizontal line reflections. And so one of the easiest way to do that is just to use the X and Y axis as a vertical and horizontal reflecting point. So let's just take a shape. Um, I've liked the triangle the last two sections. So let's take a triangle from here, just like that. And so my, oh, wrong one. Well, that's interesting. There we go. Sorry, I had some other stuff on there from the previous part of the day. Okay, so let's call this A, B, and C. And so to start off with, we're going to reflect it through the x-axis. Remember, when something reflects, it goes through it at a perpendicular. And so I'm going to take A, and if I were to extend A to the x-axis perpendicularly, then I would just count that many boxes, and obviously it's going to be 6. So I'm going to go to 6 spaces below the x-axis, and this, whoop, right here is going to be my A prime. I've reflected that. And then C, I can do the same thing. I take my C and perpendicularly it goes down 3 spaces. So I'm going to go down, after I get rid of that, I'm going to go down 3 spaces to -3, 5, -3, and that's C prime. And then doing the same thing with B. I'm going to stretch that there. That's going to be 5 spaces. So I'm going to go to 8, -5 in this case, right here. And that's going to be B prime. Oop. There we go. Crazy looking B, but it gets there. And now I'm going to connect that shape. And I don't know what happened next to that A, but there is my triangle reflected through the x-axis. And so now I'm going to pretend that that never happened. Oh, look at it go away. I don't know where it went. And there it's back again. There we go. I got to get rid of that triangle. Excellent. Okay, so now let's look at it and reflect it through the y-axis. Again, you can go ahead and work ahead of me if you would like. You can probably see what's going to happen. So A is going to be 3 spaces over. I'm not going to draw the dashed lines this time because 3 spaces over is going to be here. And that's my new A prime. And then B is going to be 8 spaces over. So that's going to be here. There's my new B prime. And then C is 5 spaces over. And so there is my new C prime. So just basic through vertical and horizontal lines. Okay, so we're going to take it another step and finish this one off. We're going to actually plot the line segment FG. So F is -1, 2. And there's F right there. And then G is 1, 2. Right there. And what we're going to do is we're going to reflect this through the line y equals x. Now that's a very common line, and it is just what it is. I mean, if I made a if I made a little t chart here, and if x is 1, y is 1, x is 2, y is 2, again, because y equals x wherever we go, we could also throw 0, 0 in there. So that line is going to look like this. Let's see if I started it at 8 negative. Oh, I don't want the dash line. I want a regular one. So if I started at 8, 8, and just went down, there's the line y equals x. And so that's what I'm going to be reflecting it through. Now, the key here is that I have to, no, I'll go ahead and connect this line here. That was horrible. No, I don't like that one a lot better, but there we go. I like that one a little bit better. So if I'm going to reflect that, I need to reflect both of those points individually. Again, this was negative 1, 2, and this was 1, 2. And to do that, I need to remember that perpendicular relationship. I also need to know the slope of y equals x. So the slope is the number in front of the x, remember? So our slope is 1. So from each one of those points, I need to go at a negative reciprocal slope. So the negative reciprocal slope is going to be negative 1 over 1. And so I go to point F, and I go down 1 to the right 1, and then down 1 and to the right 1 again. And so you can see, and let's see, how do I want to draw this? Down 1 to the right 1. So I understand that that my line is going to go, I'm going to draw this one as dashed. Before I do that, I'm going to draw the points. I'm going to draw my down 1 to the right 1, which would be there. Down 1 to the right 1 is there, 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 there. So there's my line going that way. I'm going to draw that dashed. That is a perpendicular because it has the negative reciprocal slope of that. Now, here's the key. Where did it intersect my line y equals x? Well, it appears that I go down 1.5 and to the right 1.5. So I'm going to do the exact same thing and go down 1.5 and to the right 1.5, which is going to end up right here. So there is my f prime. Now I look at G, and I also want to draw a perpendicular with it using the exact same negative 1 slope. So I go down 1 to the right 1, down 1 to the right 1. So it is going this direction. I think we can pretty much see where that's going to go. It goes down half a space over half a space. So if I go down half a space over half a space, I'm right here, and that's my G prime. So my f prime is 2, negative 1. And my G prime is, where am I at there? I am at 2, positive 1. And I could go ahead and draw that in. That is right there. And so what I'm going to do now is kind of clean this mess up a little bit. I'm going to take these out of here. Excuse me, sorry about that. And then that shows a little better representation of f prime and g prime. Okay, the final Final topic is just basic lines of symmetry. I don't know if they play it anymore, um, but there used to be a game called Fruit Ninja where you would just cut all these watermelons and fruits and everything, and it would just cut them in half or sections. So that's basically what lines of symmetry are. If I was going to take a square, and how many places could I cut that square in where if I folded it over, it would be the exact same shape? And so obviously I can hot dog it. That's horrible positioning. I'm way off. I could hamburger it, and then I could also diagonal. Again, I'm a little bit off on these guys, sorry. And so that square would actually have 4 lines of symmetry. There are shapes that have infinite lines of symmetry. If you took the diameter of a circle, you could use that infinitely. And there are some that don't have any lines of symmetry that you couldn't fold over and have it be equal on the other side. Maybe a just kind of an irregular triangle right there. There's no place in that triangle where I could fold itself over and be exactly the same on the other side. So some will have a few, some will have infinite, or one will have infinite, excuse me, and some will have none at all. And that is Chapter 4, Section 2, Reflections.